All right, kids. You started in 10th grade. You started in 10th grade learning about sine, cosine, tangent. And then this unit, we went even deeper. I got breaking news for everyone. There's 3 more. You got sine, cosine, tangent, and there's 3 more I'm going to show you today. All right? First one, let me introduce it. It's up top in your box on your notes. Anybody want to try to pronounce it? Secant. Secant. Let it roll through off your tongue a couple times at home too. Secant. That is the 4th one I'm going to introduce. Secant. But here's the good news. It's related to one of the 3 you already know. It is related to cosine. Basically, here's what I do. I take the whatever fraction cosine's equal to, I flip it. And I get secant. All right? I flip cosine and I get secant. So let's take this even deeper right now. Let's make secant equal to a couple more things. Hey, what's cosine equal to as far as SOHCAHTOA goes? What's cosine equal to as far as SOHCAHTOA goes? Adjacent over hypotenuse. Flip it, and you get secant. Go ahead, flip adjacent over hypotenuse. What do you get? Hypotenuse over adjacent. So that is what secant is equal to. It's the hypotenuse side over the adjacent side. Hey, let's take it a step further. Everybody go to the unit circle right now in your mind, the unit circle. What coordinate have we been talking about equals cosine? What coordinate equals cosine? Coordinate. What coordinate equals cosine? X. So I flip it, and secant is 1 over x, the coordinate. 1 over the x coordinate is secant. All right, there's your 4th one now. You have sine, cosine, tangent. You now have secant. I'm just going to just stop and let that marinate right now in your mind. Secant. It's related to what again? Cosine. Okay, related to cosine. So there's your 4th one. The 5th one. Anybody want to try to pronounce the 5th one? Number 2 up there. Cosecant. Cosecant. And you guys can see what it's equal to. Cosecant's related to sine. So anything that's sine, flip it, and you get cosecant. Should have wrote this at the beginning. What's sine equal to if we're doing SOHCAHTOA? Opposite over hypotenuse. Flip it. So how do you find the cosecant fraction? Hypotenuse over the opposite side. We're going to practice all this today. Okay, now everyone go to the unit circle. Go to the unit circle for me. What coordinate was sine on the unit circle? The y coordinate. So flip y, and you get 1 over the y coordinate for cosecant. And because it's brand new, I got to sound like a broken record here. Secant is related to what? Secant and cosine. Cosecant and sine. We got to know they're related because I know I need to flip 1. And then you're ready for the last one, the 6th and final one. This one's probably easier than the other 2 I showed you. How do you pronounce that one, the last one? Cotangent. That's pretty easy. It's got to be related to what? Cotangent. It's got to be related to tangent. Okay, so let's keep going with our definition here. What's tangent as far as SOHCAHTOA goes? Opposite over adjacent, flip it. What's cotangent going to be equal to? Adjacent over opposite. You guys remember we just did 2 days of it. On the unit circle, how do you do tangent? Because there's no more coordinates left. How did we find tangent on the unit circle?
X over Y.
No. Y over X, right? Tangent was Y over X on the unit circle. So what's cotangent? X over the X coordinate over the Y coordinate for cotangent. All right? So now we have, so let me go back to, and this may help some of you keep track of what's what. This helps me a lot. SOHCAHTOA, ready? Tangent. Flip it and you get what? What are we calling that new one after we flip tangent? That's called?
Tau.
No. Flip tangent. What are we calling this?
Can I shut the door?
Cotangent, right? I know. I'd be embarrassed too, but. What's your deal?
I don't know.
Did you just knit that thing today?
No, I got this at Goodwill.
Oh, okay. Hey, whatever floats your boat. Oh, you may have just knitted that thing. You guys at home have no idea what I'm talking about here, but looks like Caroline just knitted her shirt today. Okay. No, I'm good. We're good. I believe you. Tangent and what go together? I should have said that. Tangent and what? Cotangent. So underneath, I'm going to write COT for cotangent. Just so you can keep track. Watch this, and I got a little magic trick at the end here. Cosine and what go together? Cosine and, you can still cheat. Secant. So I'm going to write SEC for the abbreviation underneath cosine. And what goes with sine? Cosecant. If this helps you out, guys, write it. SOHCAHTOA with what it's related to underneath. Now, the biggest thing kids mess up is they forget cosecant and secant. Which one goes with which, right? Because cotangent's easy. We know which one. It's got the word tangent in it. Ready for a little trick? Ella, you ready for this one? Yeah, you are. How do I remember which one goes with which? SEC is another abbreviation for what word in the English language? Second. So it goes with the second one in SOHCAHTOA. You like that, Colin, didn't you? You like that. Yep. Everyone see that. So you don't have to get messed up what goes with what. All right? SEC is another abbreviation for second. So it goes with the second one in SOHCAHTOA, which is cosine. All right, so I'll leave that up here. All right, problem number 1. You used to do 3, now you're finding all 6 of them for me using this right triangle. All 6, and somebody keep reading. What angle am I going from? For which angle? I'm finding all 6 for which angle? Angle A. So we're going to look at angle A when we answer this question. I will start it off. I'll start by finding sine A. Okay, let's find sine A together. We could have found anything, but I just chose sine A. Ready? Sine A. Opposite, because we're dealing with the right triangle, I'm going to use SOHCAHTOA. Opposite over hypotenuse. What's opposite? Square root of 7. And then what's the problem we run into? No hypotenuse, but you're more than capable of finding it. How? Pythag. Pythag, right? We can do Pythag to find the hypotenuse. So off to the side, 3 squared plus radical 7 squared equals c squared, the hypotenuse. All right, let's find the length of the hypotenuse so I can plug it in.
Oh, sorry.
It's all right, Caroline.
It's not my gun.
Are you guys getting 4 for the hypotenuse? 4. So it's radical 7 over 4. All right, we still got a couple more to go, though. So I just found sine. I'm going to suggest now, ready? You find cosecant of A. Why? Anybody know why I'm going to suggest you do cosecant now? Because sine and cosine are related. What do I just have to do with sine to find cosecant? Flip it. So instead of radical 7 over 4, it's going to be 4 over radical 7. Everyone? Now, did I have to do cosecant? No, but I was like, hey, I just found sine, so I might as well find its reciprocal, cosecant. And anybody going to tell me why I don't have any self-respect right now?
Yeah.
You have a
I have a radical in the denominator. No self-respect if you have that. How do I undo it? How do I get rid of radical 7? Multiply top and bottom. We don't cross multiply, right? We don't cross multiply. We just multiply top times top, bottom times bottom. So the cosecant's going to be 4 radical 7 over 7. Everyone okay? All right, I'm going to let you guys take over now. You tell me. And also, too, I'm tired of just doing math and answering math questions here. We're going to liven it up a little bit, and some of you are going to hate this, but I want to learn more about you, too, because I know nothing about you. I see some of you guys, I see everyone 50% of the time. So before you answer my question, first question you're going to answer is one food for the rest of your life. What's it going to be? Got it? One food for the rest of your life. What's it going to be? And then I'll probably critique it, and then you can answer my question. Okay? Here we go. Let's start this off here. I'm very interested in all this. You ready for this game? Yeah. Okay. All right, let's start it off right. Sophia, what do you got for me?
I don't know.
Not acceptable.
I don't know.
There's got to be something out there that you enjoy.
I enjoy like everything.
Well, you got to pick something that you're going to eat for the rest of your life.
Just to spite you, and everything bagel.
Yeah.
Whoa. All right, I see how you went there. Everything bagel. Okay. All right. Would you put anything on it?
Cream cheese.
What kind? Just plain or veggie or extra? I don't know. I don't eat cream cheese, but
Veggie.
veggie?
Yeah.
Healthy.
Yeah, you're gonna have the worst breath ever for the rest of your life. But hey, that's what you want. Toasted or no?
Yeah, toasted.
Toasted. Okay. All right. Anyway, hey, you get your choice. So there you go. Despite me. What do you want to find next? You got 4 more to find. What do you want to? I got sine and cosecant done. What else we want to find?
Cosine.
Cosine. Let's do it, everyone. Cosine A. Can you find cosine A? Adjacent over hypotenuse. You guys help me out. What's adjacent to A? 3 over hypotenuse? 4. Everyone okay where we're getting those values from? Adjacent over hypotenuse. Okay, keep in the pattern right now. Keep in the pattern. We just found cosine. Katie, here we go.
Am I still picking up food?
Darn right you are.
Oh, okay. Sushi.
Oh. Is there? I don't know. I hate sushi. But I've never even tried it. I won't even go
I
near
like California rolls.
Okay. What's in? I know rice, right? Some fish.
Yeah, it's like no, it's crab.
Oh, excuse me. Crab.
Yeah.
Is there any dipping sauce or no? I have no idea.
Yeah, soy sauce.
Okay. Okay.
Yeah.
Is there anything else I should know? Because I have no idea about sushi. Is there anything else I should know about it?
Not really. I don't know.
Okay. Sushi. All right. Anybody else sushi people? All right. Okay.
Vegan sushi. With avocado.
Okay. Easy there. All right. Why don't you just go give me a quilt? Okay. And we'll talk.
Okay.
Okay.
My grandma.
All right. Enough. All right. Enough. Trying to make me feel bad. All right. Okay, Katie. We just found cosine A. What did we call our new function that's related to cosine?
Secant.
Good. So we'll find secant now because how do I find secant? I just do what?
1 over the cosine.
Well, I don't even need to do that. I already know cosine's 3 over 4. So just
hypotenuse over adjacent.
yep. And if if cosine was 3 over 4, what's going to be your secant?
4.
Yeah. Keep going.
Over
Just flip it. Yeah, 4 over 3. You're fine. Just flip it. Everyone see where we're going now. When you're doing SOHCAHTOA anyway. All I need to do is, I need to make sure I know what it's related to and flip it. All right, I got two more to go. Caroline.
Either mac and cheese with breadcrumbs or.
There's not a choice. One food for the rest of your life.
Okay, probably that.
Mac and cheese with breadcrumbs.
Yeah.
Okay. Is there a certain restaurant, homemade?
It's all that's my go-to. So, okay, Druthers, except the C in there is not my favorite. Too many like TVs.
But you just have Druthers. You don't care where you eat it.
Okay, but that's
Druthers mac and cheese.
Or
No, that.
Old English pub has good. Okay.
One.
Wait, Druthers mac and cheese.
Okay. Just the plain mac and cheese, because I know they have other varieties.
Yeah, just plain. No.
Okay, Will, this isn't your show. Zip
I'm
it.
just saying it's good.
I'm vegetarian,
Okay, that's fine.
so I can't have the pulled pork anymore.
Okay, so it's just straight up
Yeah.
mac and cheese.
Yeah.
Okay, good. That's good. I like it. What are we gonna? We still have one more to go.
Tangent.
Tangent. Yep. Tangent of A.
Radical 7 over 3.
Opposite radical 7 over 3. Good. And then we'll just keep. I won't even ask anybody. Now we'll find cotangent, and all I'm going to do is flip tangent. 3 over radical 7. What's the problem again, everyone? I have a radical 7 on the bottom. That's not going to fly, so make sure we get rid of it. Radical 7 over 7, so we end up with 3 radical 7 over 7. Everybody picking up this concept. I got to flip one of the main 3 to get the new 3. I just got to make sure I know which one goes with which. All good here before I go on to something different. Okay. Sine, cosine, tangent. Where are they positive? Where are they negative? And then we'll start and I'll talk about the new 3. All right, so I just want to remind you, all students take classes. That reminds me of where everything is positive and negative. All right, so let's just fill in the chart for cosine, sine, and tangent, and then I'll talk about the new 3, all right? All right, here we go. 15, here we go. Katie, back to you. You don't need to tell us anything else. What do you know about the first quadrant? What's positive in the first quadrant, Katie?
Everything's positive.
Including our new 3. Okay, everyone, including our new 3. Everything still remains positive in the first quadrant, including our new 3. So everything, all are positive in the first. Good job. All right, let's move to the second. What's positive in the second? Bassett, here we go.
Cosine.
Not the answer I was looking for. You know the deal.
What do you mean, like, what's negative in there?
Nope. As in, what's Bassett's favorite food in there?
Oh, that?
Yeah.
Probably salmon.
Okay. Again, I'm not a fish guy, but salmon. Do you fry it? How's that done there?
Grilled.
Oh, okay. Grilled. Do you put any like lemon squirts? Is that the correct one? Like lemon, whatever on there?
Yeah, sure.
Any other toppings or dipping?
Not sure.
It's your favorite food, boss. How are you not sure? Salmon, okay. All right. Like the middle part of the salmon, the fish part, you don't eat the head or the tail. You're not a savage,
no,
are you?
Fish
Okay.
No.
Okay. All right. Decent. Salmon. Got it. All right. Second quadrant, Bassett. Second quadrant, what's positive? ASTC. What's the S mean in the second quadrant?
Sine.
Okay, so
Sine positive.
sine. Okay, now one more question, Bassett. What was the new one that's related with sine?
Cosecant.
That's also positive. If sine is positive in the second, so is its reciprocal, cosecant. Everything else, guys, negative. Okay? You picking this up now. Not only is it positive in its quadrant, but so is its reciprocal. Let's go to the third quadrant now. Third quadrant. Katie, back. Nope. Sophia, going to you now. What's positive in the third? Then why did I put a T there, not an N? Tangent, good. So tangent is positive in the third, so a plus here. What's related to tangent? So that is also positive in the third. Everyone's seeing that. All right, so not only are whatever letter I have in there is positive, but so is its reciprocal. Everything else, negative. And then finally, fourth quadrant. What do we know is positive in the fourth quadrant? Dan? No, you don't.
In the fourth quadrant?
No.
Oh, wait. I don't know.
There you go, Dan.
Favorite food, probably.
Or food, no, one food for the rest of your life.
Oh, one food for the rest of my life. I have to choose. Probably lobster.
Oh. A lot of butter on the side to dip that sucker in?
Yeah.
Okay. Anything else you put on the lobster or just the butter?
Just the butter. Don't want to make it too fancy.
Sure, you're right. You're right. Nice little bib tucked in so you don't get all sloppy.
Yep.
Okay. Are you a claw guy? A main part of the lobster? I don't know what it's called, but I'll call it the main part.
I think probably just like I guess, yeah, you call it the main part.
Okay. Nice. Have you ever cooked one before?
No.
No? Okay. All right. What, you got?
My dad bartends at the Red Lobster.
Yeah. Hey, you got to put it, take it out, put it in. See ya.
The
Have a good
kids-
one.
The kids don't know.
Okay, anyway. Okay, Dan, going back. What's positive in the fourth quadrant, Dan?
Cosine.
Okay, cosine, yep, cosine, and what's its reciprocal? What did we call it today? What's it related to?
Cosecant.
Oh, that's related to sine.
Oh, secant.
Secant. So both are positive in the fourth, everything else negative. All right. Questions? So does everyone understand? We knew where these were positive, but now also what they're related to is positive there as well. So let's answer some questions now on it. Determine if these are positive or negative. Cotangent of 340. Cotangent of 340. Is it positive or negative? First, you got to know what quadrant you're in. What quadrant am I in? 340? I'm not going to call on anybody here because I want to pick it up a little bit. 340, what quadrant? 4. Okay, so this is cotangent, which is the same as tangent. If you want to write tangent above it. What do we know about those two in the fourth quadrant? Negative. Okay, negative. If you're not sure, stop me and ask. Secant, 123, positive or negative? Well, where's 123? 2. Secant is related to which one? Cosine, all right. What do I know about cosine or secant in the second quadrant? Negative. Done. Keep going. Cosecant, 184. Where's 184? 3. What's cosecant related to? Which one of the 3 originals? Sine. Okay, what do I know about sine or cosecant in the third? Negative. Because tangent's positive there. All good? Going too fast? Everyone at home all right? All right, next one. Now I'm going to put the inequality symbols in. If cotangent less than 0. Guys, that's a fancy way of saying what? Cotangent is negative. So cotangent's negative. And secant is greater than 0. Greater than 0? A fancy way of saying it's positive. So what quadrant? Don't worry about the final answer yet. What quadrant do I have cotangent negative and secant positive? If you don't like cotangent, what's related to it? Okay, so if you don't like that, write little tangent above there. What's related to secant? Write cosine above if you don't like that. So where do I have tangent negative, cosine positive? What quadrant? Quadrant? Well, tangents, everything's positive, right? Nothing's negative in quadrant 1, right, Colin? So quadrant 4, I know I'm in quadrant 4 because that's where cosine's positive. All right, so which one of these angles is located in quadrant 4? 310. There we go. You're going to get a couple of those on the quiz Thursday and Friday, except it's going to say cotangent, secant, and cosecant instead. All right, next one. Got your calculators ready? Use them to find these values to the nearest thousandth. Cosecant of 63. Now, hey, we can search and search. You're never going to find a cosecant button on your calculator. It's not on there. It's not on there. So how do I find the value? Go back. What's cosecant related to again? Sine. But it's sine flipped. So ready, watch. What I'm going to do is I'm going to find the sine of 63, but flip it. All right? I'm going to take the sine of 63 over 1 and flip it. That's what I'm doing to find cosecant. All right? I'm flipping it. You guys have a sine button, right? Make sure you're in degree mode. All right? Make sure you're in degree mode. And then thousandth is how many numbers after the decimal? Thousandth? Oh boy. 3 numbers after the decimal. So 1.122. Okay, you're not going to find these buttons on your calculator. You got to know which one to flip. So number 2, cotangent of 245. What are you going to? You don't have a cotangent button. What are you going to type in your calculator instead? Don't type in tangent of 245. You want 1 over the tangent of 245 because you're going to flip it. And I'm getting 0.466. And then how about secant of 35? What's secant related to? Cosine. Don't do cosine of 35. 1 over cosine 35. You got to flip it. Got to flip your value. Let's see. 1.1. There you go. Got a rounding magician in the back there. Good job, Colin. All good? Okay, so you're not going to see those buttons on your calculator. So here's what we've done so far. We've gone SOHCAHTOA. Where is it positive and negative? The only thing we haven't gone to yet that we've reviewed already in this unit, the unit circle. Okay, how can we use these 3 new ones on the unit circle? Remember for tangent, hey, guys remember for tangent, we got a couple answers that were undefined because we got what in the denominators? What number did we get in the denominator? And we said, oh, that makes it undefined. 0. That's going to happen for some of these new ones too, where you're going to get 0 in the denominator. That's what I want for example number 6. Which value is not in the domain? Basically what I'm asking is, guys, where is it undefined? Okay? Where is cosecant undefined? You ready to go through the choices with me? 180. All right, everyone go. 180 on the unit circle. What do you got? What's the coordinate? -1, 0. Okay, I'm going to slow it down a little bit now. Take a breath. I'm doing cosecant. Cosecant. Can you do it without looking back? What's cosecant related to? Sine, which is what coordinate on the unit circle? Y coordinate, but I'm going to flip it. Right? I'm going to do 1 over the y coordinate. So this one at 180 would be 1 over, what's your y coordinate? 1 over, what's my y coordinate at 180? 0. What's going to happen here, guys? Undefined. Yep, I don't have to even check anything else. Cosecant is 1 over the y value, remember. 1 over the y because it's related to sine. Questions? Kian, you're right back here? Okay, good talk. Anything else? Okay, here's where we're going to end it. This is where you guys, you didn't have good progress on the quiz on these. So everyone see these right here? I put them on the quiz again. Okay, except they won't say sine and cosine. They're going to say tangent, cosecant, cotangent instead. All right? I need a point on the unit circle, guys. That's what I'm looking for here. Use the unit circle, please. Secant of 60. Secant of 60. I'm not even going to say a word. I just want to know what you're thinking. Secant of 60. Remember, it says exact value. So no radicals, no decimals. I want radicals or fractions. Okay, secant of 60. Who's going to help me out here? Boom. 10. Caroline, ready?
Yeah.
Okay, I just want to know. You see secant, you see 60. What's going through Caroline's mind?
I'm thinking you would get the ordered pair.
Okay, 60. Go. That's a good start. 60. What's the ordered pair?
1/2 radical 3 over 2.
Okay, so you saw 60 and you thought of that. Perfect. Now we're going secant.
That's cosine.
Cosine, keep going in your mind. Cosine is what coordinate? X, right?
We put 1 over.
Okay, yep, ready? 1 over 1/2. Or, I'll show you this at the end if anybody wants to do this.
And then do that math.
You did, yeah, you've done it the last 2 days. Isn't this keep, change, flip?
Yeah. Oh.
Right?
So
1 times,
2 over 1.
so it's going to end up being just,
2.
yep. Also, I don't know if anybody thought this. You just flipped cosine, right? Flip the cosine. Cosine is which coordinate again, Caroline? X. So what was our x coordinate?
1/2.
Flip it. What do you get?
2.
Done. Okay, so I could have done it that way too. You can do 1 over the x, or you can just flip it. All right, kids, all right? Good job, Caroline. Good thinking. All right, who's doing part B with me? Not yep, Caroline, you're good. Oh, here we go. Mason, ready?
30.
No, stop.
Oh, sorry. Eel. Just raw eel, nothing on it.
Okay.
What?
Don't judge. There's no judging. This is a judgment-free zone.
No, I'm not. That's.
Do you, what's the word I'm looking for? Skin it?
Yeah.
Where do you get?
You can just buy a whole eel.
Where?
At the Asian market is where I typically get them.
Oh, the Asian. That's cool.
Just plain? No dipping?
Mhm.
Really? Cooking? Do you cook it?
Nah.
Raw?
Does it have eyes?
Yeah.
Do you eat them?
Those are gross.
Okay.
He's not a savage. Just stick to the eel. Okay, that's an interesting one. Eel. Okay, man. Hey, you got it. I'm all for it. Okay, cotangent of 150. What are you thinking?
Oh, it's 30 off 180, one of the axes.
Okay, so Mason says, hey, that's a reference angle of 30 because I only know coordinates that have 30, 45, and 60. All right, keep talking to me.
So it's radical 3 over 2 and then 1/2.
Yep. Cotangent now.
Cotangent,
Yep.
which is the x over y.
Good. X, usually cotangent's y over x, but I flip the order and do x over y. Got it? All right, so give me the x.
That radical 3, 2.
Yep. Over the y.
1/2.
Over 1/2. Good. We know we're not leaving it like that. Looking that crazy. Keep, change, flip. So radical 3 over 2 times what, Mason?
2 over 1.
Yep. What cancels?
The 2's.
2's are gone, and what are you just left with?
Radical 3.
All right. There we go, kids. Good work. No, he's wrong. Oh, look at all the heads pop up. One thing we didn't take into account. Oh, what am I talking about? Where's 150, Mason?
150 is in the second quadrant.
And what do we know about cotangent or even tangent?
It's negative.
It's negative. So that's another thing we just got to keep in the back of our minds. Great job all the way through, except we got to remember it's negative because it's in the second quadrant. You kids at home, all right? Great job, Mason. Great job. All right, who's finishing this with me here today? Same numbers here. Dan, I already heard from you. Dan, great job. There we go. Hi, Anna.
Hi.
How are you?
I'm good. How are you?
I'm doing great. Think we can get through this in 2 minutes?
Yeah.
Okay, quickly, favorite food or food for the rest of your life?
Sesame chicken.
Oh, okay. That's a good one. I like it. Approval. All right, what's yeah, you're welcome. I'm in radians, Anna, and I can only do degrees here. So do you remember what pi over 4 was in degrees so I could do this quickly?
45.
Yep, so we're going to do 3 times 45. So that's going to be the cosecant of...
135.
Okay, here we go. Now talk to me, Anna. We're going to do cosecant of 135. Where are you going?
What? It's the sine.
So, okay, yep. So you're going to do the y coordinate, right?
Yeah.
You're going to flip the y coordinate, but I need coordinates to begin with so I can flip it.
Yeah, so from the reference angle.
Okay, go ahead.
180 minus 135.
I'm listening. 45, good. So everyone, we're at 45. What do you got on the unit circle, Anna?
Radical 2 over 2 and radical 2 over 2.
All right, and you said flip which coordinate?
The y.
Okay, so radical 2 over 2 flipped is 2 over
Radical 2.
radical 2. Everyone's seeing where we're getting that. We're flipping the y coordinate. Do you like that, Anna?
No.
Nope, why not?
Because there's a radical in the denominator.
All right, how do you get rid of it?
Multiply by radical 2 over radical 2.
All right, keep going.
2 radical 2 over 2.
What's up, Caroline?
I think I missed something.
And then, so get rid of the 2's, radical 2. Last thing, what quadrant are we in?
The second quadrant.
And what do you know about sine and cosecant in the second quadrant?
Positive.
Positive, so we're going to keep it positive. All practice tomorrow. All practice. Good job, guys, today. I learned a little bit more about you. Question there, Caroline? See you, Isaiah.
Thank you.
What's up?
Secant sine.
No, that's not secant. That's cosecant.
Cosecant
It's sine, yep.
sine.
Sine is the y coordinate on the unit circle.
Okay.
So I took the y coordinate and I flipped it. You could do 1 over that too, same thing.
Okay. Yeah, you flip it.
Okay? And that's what I get when I flipped it.
Oh.
Get the radical out of there.
Okay.
Can we meet after school Wednesday? To review a little bit?
I'll be here after school Wednesday. Yep.
Have a good one.
You too.
Bye, thanks.
See you, Caroline.
See ya.
You good?
Yeah.
Okay. Okay, here we go, kids. A couple reminders. You guys in class have your test on Thursday. You guys at home have your test on Friday. I'm not going to talk about your test until tomorrow, so I'll leave that. Just want to remind you do have one coming up. First grade of the second quarter. It covers a pretty big unit, as you can see from your packets. I have no idea when we started this. It seems like forever ago we started this unit. But we're going to end it on Thursday and Friday. All right, let's get organized. All right, looks like we are going to your 5 proofs from last night. There will be 3 proofs on your test, if anybody was wondering. 3 proofs. Yes, the 5th proof, the 5th and final one, was the toughest one probably we've done all year. Say that again, Krista. What's it? The assignment sheet?
Yeah, on the assignment sheet, it's L through K for both Thursday and Friday. I was wondering if you could change that maybe.
I will. If it's bothering you, yes, I will. Okay. L through Z takes it on Thursday. A through K takes it on Friday. All right. All right, let's do this. Yes, I know. The last proof was very, very tough. I know. Finding that third and final pair, it was tough. Why don't we just go right to it while we're here? Okay. Where you should be at least with this proof, you should be able to find a pair of triangles to prove congruent. Okay, you should be able to prove a pair of triangles congruent. You should have picked a pair that contained QB and QD. That should have been an easy job for you. You should have gotten at least some angles and sides in those triangles as well. If you got stuck on where to find the third pair, that's okay. I get it. All right, I get it. So let's talk about that one. Just so I know, how many of you tried to prove these 2 smaller ones, BAQ and QCD congruent? Anybody try to prove those congruent at all?
I did that.
Okay. Couple people did. All right. Just by show of hands, how many then maybe tried to prove these instead? PQB with PQD. Did we have more people try to prove those equal? And if you didn't prove either ones, I don't know how you did the proof. Is there another pair up there I don't know about? Here's what I'm trying to ask you guys. Which pair am I going to try to prove congruent here?
The one you have highlighted.
Okay. We're going to let Adam make the decision. Got it. All right. So I'm going to try to prove those two pair equal up there. Congruent. Here's what I know so far. I gave you angle 1 congruent to angle 2, which is a pair of angles. I also gave you, I didn't give you anything else, but at least I'm hoping you saw it shared a side, QP. So I'm hoping that went in your proof. QP congruent to QP, because that gave you a pair of sides. Two pair, right away, two pair. And just where the heck the third pair come in? That was the toughest part. Here's how the rest of the proof is done. Also in the givens, I gave you AP congruent to PC. Why are those two triangles now congruent? Why are triangle AQP congruent to triangle CQP? That's side angle side. And yesterday I said, hey, after you prove those triangles, try to look for sides or angles that are also in the triangles you're trying to prove. And you didn't have any. That's why this proof was so tough. You didn't have any triangles, you didn't have any angles or sides. Here's what I needed to do. Look at these angles right now. Angle AQP congruent to angle CQP. I'll mark them here. This angle and this angle. Everyone see they're in the triangles I just proved congruent by side angle side. So they're congruent by CP, CTC. Everyone all right at home? Good? Where am I going with this? One more step. What type of angles are these right here? BQA and DQC? Those are vertical, aren't they equal? And look, ready? How am I going to get a full angle right here now? Addition. That's how I got the third pair, if anybody's wondering, in that third set of triangles, all right? Here was your third pair. Angle BQP congruent, oh, come on. Angle BQP congruent to angle DQP by addition, substitution. Addition and substitution. And then it would have been angle side angle to prove the triangles congruent. The two big ones. That was tough. That was hot. That was high level right there. Anything you want to go ahead, ask all your questions about number 5 here. Well, maybe
okay?
Go ahead.
Is it okay if I solved for BAQ, like triangle BAQ is equal to DCQ?
Yep. That's a little bit. After you still should have proved the two smaller ones by side angle side, Owen.
Yeah, I did do that, and I used that to do the next part.
Yep. It would just have been a little different than what I just did there.
Cool.
Yes, you could have proven the smaller triangle. So here you go. Ready? Just so we're all on the same page, everyone. How to get these two smaller ones equal. You still go vertical, right? You still have vertical. After you prove the side angle side triangles, now you say AC is congruent, or AQ is congruent to QD, CP, CTC. And then you took these angles here that are congruent by CP, CTC. And what's next to them, guys? Congruent supplementary angles. Yep. So now you had angle side angle for those two. How's that look, Owen?
I did it that way.
Okay.
I think maybe I did it wrong, but I think you marked the wrong, you were supposed to mark.
Yeah, I did.
C.
Settle down, all right? Settle down. I should have marked these two. There you go. Settle down. Anything else on that one? Okay, that was the only proof that involved proving another set of triangles congruent. All the remaining 4 proofs, you did not have to prove another set of triangles congruent. I don't think anyway. If you did, you made your proof a lot longer than it needed to be. Okay, there was none of the other 4 involved proving 2 sets of triangles congruent, just the 5th one. Is there anything else we need to talk about?
Can we look at number 3? Diagram really threw me, and I was trying to figure out what to use.
Okay, start here, Sarah. What are you trying to prove congruent?
Side DB is congruent to side CA.
Okay, so now I say, all right, do I know can I find a pair of triangles that have DB and CA as sides? And there's only one, here's the thing, Sarah, there's only one pair of triangles that do. Do you see the 2 triangles that contain DB and CA?
Yeah, DMB and AMA, or CMA.
Okay, here you go. Let me highlight them because you're correct. DMB and triangle AMC. Sarah, if you can get these 2 triangles congruent, you're good to go. So can I get them congruent? Give me a given, Sarah.
Yes, because you can add and substitute.
Okay, hold on. Let me just go through how to prove them congruent. What's one of the read off a given for me? One of the givens.
The angle D is equal to angle C.
There's a full pair of angles, right?
Mm-hmm.
Okay, what's the next given?
M is the midpoint of side DC.
So that means which 2 segments are equal?
DM and MC.
Okay, there's a pair of sides right there. Right? Everyone's with me so far. Pair of angles, pair of sides. Definition of a midpoint. Here's the hard part. The 3rd given was 1. Take a look, everyone. Look at angle 1. That's not an angle in my triangle. It's part of one, but not a full one. And angle 2, same thing. That's part of an angle, but not a full one. How do I make them full ones? You add angle A and B to both of them. You add angle A and B to both of them, and then you get full angle DMB congruent to CMA. All right, everyone good? Did anybody, instead of adding and substituting, anybody use supplements of congruent angles or congruent? Because you could do it that way too to get those angles equal. You could do it that way instead of reflexive addition substitution. Any others on those proofs we need to talk about? Yep.
Number 2, I did something.
Okay, same thing, Quinn. Here we go. I'm trying to prove 1 and 2. So what triangles are you going to tell me to try to prove congruent?
Triangle ADC and triangle VAC.
Okay. There you go. This one right here, along with this one right here. They share a side. I also told you, ready? I told you DA was congruent to EC, so there's 2 sides. Good so far. And I also told you that BD and BE were equal to each other. Okay, so you have 2 pairs of sides. So where did that funky 3rd pair come in? If you add these 2 and add these 2, what sides are equal?
BA and BC.
Making it what type of triangle? What's across from BA and BC?
Equal angles.
Name them.
BAC and.
Hold on, you see how that's a 1 in my yellow one? And also congruent to?
BC, right?
You see how that's 1 in my orange one?
Yeah.
What method do I have now?
Sine angle side.
CPCTC.
Right.
Okay?
Yeah.
Others? Anything else we want to discuss? All right. You guys at home, clean it up. Here we go. You guys here, I'm going to see it. Take a look at them.
So for this one, I'm going to try and prove this triangle congruent to this triangle,
Okay, yep.
and then this triangle congruent to this triangle. And then I said that with CPCTC, I could say those two sides were congruent, and then do the isosceles.
So you ended up proving
Two triangles.
these two here?
Yeah.
Okay, so you had the vertical angles, and then you proved the two overlapping ones first. Okay, what parts did you use from there?
So
Like where your CP, I see what you're doing, because I see the vertical angles, and AD was given equal to EC.
right. And then I said that angle was congruent.
Oh, then you did angle side,
Yeah.
and then CPCTC,
And then
those two sides, and then it was like, yeah,
all right.
that's fine with me.
Okay.
Yeah, I'm good with that. I see how that one flowed. I'm good. Whew. All right, so on you guys, homework's good. All right, last day of the unit, and I want to mix in some middle school topics here.